Yeah, so it allows them to breathe through. We still want air gas exchange through these. You guys want to look up here at me? So your vial, foam cap, you can squish this into a tiny ball and then it comes back to its normal size. You can just kind of plop that in there, okay? It may not seem like it's tight in there, but the fruit flies can't get through. They're not strong, right? So we have these, what is that? So you have these foam ready to go. So when we're transferring our flies, you guys all have your container with the blue food media. That's where we're taking your flies from. And if you guys look at your flies in that container, what are they doing? They're crawling around. Are they crawling in any which way, or are they going a certain direction? Yeah, they're crawling up, like upwards, right? They're trying to go up. So in order to move them out, what do you have to do? Tap it, right? And when we tap it, if you tap it a few times, they fall down, okay, towards the bottom. You have to be firm. There you go. We're going to hear lots of tapping. You have to be firm, but you don't want to break the tube, right? It's not a contest to see who can hit the tube the hardest, because you can break these, right? So you're going to hit it down a few times. Okay, when they fall down, you're going to carefully transfer some over. And I notice that this may be difficult because the food is kind of falling apart. So you may get some food in your new vial, and that will be okay. Okay, try not to, but the food is a little bit crumbling. Are there any questions on what we're going to be doing first? Okay. Are there any questions before you guys get going? So you are taking your vial, tapping them down, okay? You're going to tap them down, quickly remove the cap, invert it, and then tap them into here. Okay? Ideally, we're not getting any escaped flies, right? But it happens. Okay? To be firm.
Yeah, but not all the way off, and then when you pull it off, you'll never
Alright, somebody get out. Okay, she's just gonna get ready.
There you go, they made this fly.
As you take that off, it's gonna put it on top of it.
It's alright, take it out. You're fine. Good job. Okay?
They may fly up on their own, guys. We see that they're pretty active, so they may fly up, and that's okay.
They going in, you getting some in down there?
Here, try this.
That's okay. That's okay. You just need a few for the observation. You have 7 or 8 in there that you still observe. So you just have to tap them back and see you've got plenty in there. You don't need all.
There you go. Nice. Good time. I saw one in the top, but you got it. Good.
You tried to escape?
Oh man.
They escaped and then fell to the deck.
Oh, they're all gone? Okay, that's fine. Just keep it.
They escaped and then
There will be some flying around, guys. It is unavoidable.
There might be. I'm not sure. I've never
this guy's gonna die.
there might be ice in there.
Hey, now what are you supposed to do? You need to know that.
They got tons if they want to be stored.
Here, 2, I'll take that.
But there might, I think there are eggs. You got some in there. So you'll keep this. You'll keep this. Choose one or you
Oh. So we all got flies transferred over. We will take the parent tube. Give me your parent tube. because there are still larvae in here, so they are still, they'll come back.
And we had put them back in there.
Oh, we did?
Yeah.
Oh.
We were done. What are you using?
Here, these are
Okay.
Okay, so now what are you doing now with your flies at room temperature? You're making observations, right? So in your first box, you want to make detailed observations? Now, should you be sitting back and trying to see the flies, or should you get really close? Get close. Unless you have binocular vision, you have to get really close. You can pick up the tube, look at the tube. You're going to make observations on what you see.
Did you get in okay?
Adam, are you going to be tweeting this?
I can.
I can't.
I was gonna send it to Secret. They have all that.
Yeah, okay. Because we want to make sure to give Dave Garvey and PA Society of Biomedical Research credit.
Yeah.
I took all the pictures last
Oh, great.
week. I'll
My,
do that.
my camera stinks. This is
I'll do
good.
that. I'll go get my
No, I
camera.
know. I did one of that too.
I just want to win that contest.
Don't worry, we'll disqualify.
Is it PSBR, Pennsylvania State Biomed?
Yeah. Yeah, I don't put that one. I have it. I just always don't think so. And these are actually the ones for tomorrow. We're actually shipping you to make sure that we do that. Yes, that's why I'm going to go to your husband on Thursday. They were on Oh, that's right. They were. I'm in the beach next to it. I get a text like that.
Here, we'll laugh at mine. So
Yeah,
it's
it's good.
Should we can try to just do that at 6:30?
What are you guys seeing?
You never know with that dough.
The ice is right there, yep.
Like they're trying to try.
So once you've made some, once you guys have made some observations, you want to get some ice in your beakers. Now, we're working with fruit flies, so does that mean we need to fill our beaker clear full with ice? No, they're tiny, right? So a little bit of ice. We're not trying to chill down a drink. So a little bit of ice. You want to grab your beaker, just like not like an inch, less than an inch of ice at the bottom. You want to come scoop some, bring it back to your table, and then once you have that, okay, you're going to put your tube in the ice, right? We don't want to put our fruit flies directly on the ice because that will kill them. But this will kind of lower the temperature pretty quickly in their vial. So about an inch of ice, and then you're going to chill it down, and then you're going to make some more observations.
How long?
Oh,
Because you want to keep the time consistent.
that's going to be the second part, not the first part.
Oh,
That's when we
okay.
design our lab.
Okay.
So just up to you guys till you see a behavior change. Okay. Go ahead and get some ice, and have a seat. Yep, so once you have your ice, you can put them in. Just kind of like nestle it in there. And it may take a little bit to see a reaction, but a few minutes.
I'm getting ice over.
You know, it's kind of set up like they make observations, and then they all, and then we decide.
Where do you find how much ice in there?
I think any more you can do.
Guys, without taking it out of the ice, if you touch the vial, can you take notice to a difference in temperature from when you first put it in there? And it may not happen right away either.
I went to Disney for 2 days. We were in Daytona Beach. And then we went to Disney for 2 days. You can't. I don't think you can easily put them on ice. Like you can do it.
I don't think they're as energetic as they were.
You might want to leave them on the ice. Reactions so they don't warm up.
Remember, a lot of them are at the bottom now.
Are they still as active?
I like the ice
Except for that one.
They're all going. Okay, so they're all going up to the one corner of the sponge at the top. So then it kind of leads you to think they're probably trying to get out. But again, when we do observations, we're going to focus on just what you're seeing. Okay? So how about on the ice? And we'll start with this group again. Then go back the other way.
Let's say this student.
Okay, not a lot of
this
movement.
week, because his family's on vacation, but he really wanted to see two of those
You can see
seminars.
them. Okay, you could actually see them moving their wings and almost like shivering.
They actually walk in and watch them. But it's one nice feature. that-
Okay, a lot less active. Staying toward the bottom. They seem to be slowing down, calming down. Okay. When they look, what does confused look like?
They were going to the top and the bottom.
Okay, so they're kind of going top, bottom, kind of all over the place at the beginning. Okay, sounds good. And then how about after you brought them back off of the ice? What did you see? They were at the bottom when you took them off the ice? Okay. So are they still there when you let them sit out a little bit?
Yeah.
Okay, they still tend to be at the bottom?
But a few are not waking up.
Okay, they're starting to wake up.
They look like they're moving to like gradually moving back up to the top.
Okay, starting to gradually move back up toward the top. Ladies? I'm not sure. Okay, then I can say that. Ladies? What else? After the ice, what do you get?
They were starting to move up now.
Good, okay, starting to move up again. Anything else?
After about 5 minutes, you can start.
Okay, after about 5 minutes, they're all moving again. Right?
We can head back, unless you want to. We can wait here for another 20 minutes.
Okay. Okay, so some of them were at the bottom, and as the glass warmed up, then they started to make their way up top again. Anything different?
They're coming through. Here comes the choo-choo train.
Okay, so the ones that they thought they were concerned maybe they were dead and they actually had froze, they actually started to move again once you got them back off of the ice. Good.
So now we all kind of agree, we have similar observations that when we put the flies on the ice, what happens to their activity? Does it increase or decrease? Decrease, right? So we can kind of run through and design an experiment and see how do you expect then the amount of time spent on ice affects the time it takes the fly to recover. And what do I mean by fly recovery? What do you think? Yeah. Like go back up to the top, right? You guys notice when you took the flies off the ice, as some groups said they thought they were dead, right? But are they actually dead? What did they start doing after a while? Well, they were sleeping, but what did they start, what was that? They woke up, right? So let's call that fly recovery. It's like the recovery time, the time it takes for the fly to kind of wake up from its chilling, okay? So moving down on your packet for experimental framework, our research question then, how do you expect the amount of time spent on ice to affect fly recovery times? So we have a research question. Now we want to make a hypothesis. What is a hypothesis? Yes, like an educated guess, right? So we've made observations. We can design a hypothesis based on those observations now. So we kind of gave you a framework to start with. So we hypothesize that blank, okay? So in your hypothesis, you want to make mention of the time spent on ice and how it affects the recovery time. So what is your prediction in your groups? Come up with a prediction based on what you think will happen as the amount of time on ice changed, how that is going to affect the recovery time. Okay, so jot down what you think your hypothesis is in that space. So you're going to relate chilling time to recovery time.
Yeah, so they would stay there until they would take them out. They would probably stay there just a little bit longer.
So the plants you have.
So it looks like we all independently came to the same hypothesis, which is the idea. Which, can someone share with me their hypothesis? Go ahead.
The more time spent on ice, the more time it takes to recover.
I like that. Anybody else have a similar hypothesis? He said the more time spent on ice, the longer it takes to recover. Raise your hand if you have something similar. Looks like we all did. There we go. All right, so if we go down then to these graphs, first of all, what type of graphs are these?
10 o'clock right now.
What was that? What type of graphs? Yeah. They are coordinate grids, right? So we always typically graph on like a coordinate plane, a coordinate grid system. But what type of graph? Is it a bar graph, a line graph, scatter plot, pie chart? What does it look like? What's in each one of these graphs? Do I have bars or do I have a line? Line, right? So we're just gonna call these a line graph, right? So looking at these graphs, what variable is on the x-axis? So x-axis, is that going to be the vertical or the horizontal line? Horizontal or vertical? is the horizontal. So the x-axis is the horizontal. What variable do I have on the horizontal axis? Independent, which in this case is what? Time on ice. So I have time on ice on the horizontal axis. Okay? And if you are going into 6th grade, you probably have no idea what I'm talking about with axes. And that's okay, you'll get that. If I am looking at the vertical, so the line going up and down, what variable do I have listed there? Time of recovery in seconds, right? So I have 4 different graphs here. Are each one of the graphs showing the same relationship? No. So we have lines in each one. So in the first graph, it looks like as time on ice increases, what happens to the recovery time? It goes up, kind of like in a linear kind of line, 1-to-1. What happens in the second graph? As time on ice increases, what happens to recovery time?
It goes down.
Goes down, pretty consistent. For the third graph, can someone explain to me what's going on in the third graph? That one's a little wonky, yeah. Yeah, so it goes up and then it kind of plateaus. Right? And then what happens in the last graph? Okay. Increases and decreases. So as a group, I want you to circle the graph below that you think best visually represents what will occur in our experiment, testing the effect of time on ice and recovery time. You're going to circle the one you think is best, and you're going to put an X through the one that you think is least likely to represent the data. So you're going to circle the one that you think is best, and X which one you think is the worst. And then you're going to tell me at the bottom, why did you choose this graph?
As the time on ice goes up. But then yeah, then it goes down.
You guys need help understanding the graphs.
So what you think is the best, so what you think is
So what do you think this one's saying? So this is so the very beginning of this graph, say it might be like 1 second or 1 minute, and then as you continue, the time is always going to go up, so it's not going to go back down again. So what this one is saying is, you know, it'll go up maybe for 1 minute, 2 minutes, 3 minutes, 4 minutes, and that's when the recovery time will take longer. But maybe if you leave the flies on ice for 5 minutes, 6 minutes, 7 minutes, then the recovery time is actually going to start getting quicker. So that's what that one's saying. So that's So that's what you guys are hypothesizing. So which graph is showing that one? Yeah. So that's the one that you think it is.
You think A is the best? Which do you think is the best?
This one means as time goes on, that happens to stay the same, but the flies in like 3 minutes longer than last. This one is, it's kind of like a 6 years and after a while, they took those out every time. That's your good, that's, okay, that's the one, then you have to, then you say, actually the one that you think is not.
And then, so the next thing you want to do is put an X through what you don't think
So
it is.
you want to circle which one here you think that. So the longer you're on ice,
So tell me, why did you choose, which one did you like?
the longer you're on ice,
Okay, so if you chose A, why do you think it's A? Okay?
this one up, when this goes up until here. You guys decide which one of these you think is best. Circle it. And then you're think you said, we're asking, did you say which one is not
Pick the best and the least, and
the least?
the least likely.
Which one do you think?
Which one's the least? So I think I said all these. Which one do you think is the least likely to happen?
So this one would be, the longer you're on ice.
Alright, and then why?
Recovery time is less.
Basically saying you have to choose the one you pick, so that's probably the one. This one is the one that shows yes, as the and this one's
This one would be, the longer you're on ice, after a while,
so they're
time is staying still, every day.
Now, as you guys are wrapping up, does someone want to share with us which graph did you choose as the best, and why did you choose that one? What do you think?
I showed the same thing as our hypothesis.
What is that?
The longer the flies are on ice.
Okay, so he's saying that A best shows what we said with the hypothesis, that the longer they're on ice, the longer that they'll recover. Anybody else choose graph A as the most likely? Like it. Anybody else want to add an explanation why they chose A? Why they thought A was the best? Yeah.
Well, because like the more time that on the ice, like more
Okay. Interesting ideas. So let's go on to the next page. 2.
Which one is, which one is not?
We can come back. Yeah. So when we're designing an experiment, we have a set of variables that we can change and we can measure. So we have an independent variable and a dependent variable. What does it mean in a scientific study, we're doing an experiment, what is meant by the independent variable? What variable is that? Yes, sir? It is the one that you change, right? So you think independent variable is the one that you can tweak, okay? So if I was studying the example they give on your sheet, time spent studying causes a change in test score. The independent variable would be your time spent studying. That's the thing that you can change. The dependent variable, on the other hand, what variable is that? Yeah. Say that again. So that's going to be your controls or your constant, okay? The one that you're measuring. So dependent variable is the one that you're measuring, so that's going to be causes a change in test score. Right? So time spent studying causes a change in test score. Test score would be the dependent variable. I like to think of it, the dependent variable depends on the independent. Dependent, what's going to change is what you're going to be interested in measuring, right? And when you're doing a controlled experiment, how many independent variables do you want to change at any one time? Should I change 10 independent variables and call it a day? How many should I change? Just one. Why is it important just to change one? Yes, sir. You can get a different outcome, right? If I wanted to look at the effect of chilling time on recovery in flies, should I also change the light that the flies are in, the humidity, the food? Should I change all that too? No, because then I get some kind of other factors affecting my results. So you only want to change one independent variable. So based on that, we're going to fill in our variables here under IV, DV, and CV. So what do you think IV stands for? Independent variable. So what is going to be your independent variable here?
Did you get it done?
I heard it. So your independent variable is going to be time on the ice, right? That's what you're controlling. That's what you are kind of changing in each in your experiment. So time on the ice. What does DV stand for? Dependent variable. What's going to be your dependent variable in this case? Recovery time. So DV is going to be recovery time.
She is one of our
And what's going to be a control variable in this case?
So I see control variable. I think like control, like things you keep constant. Is that what it's asking there?
Yeah, so I'm kind of hesitating only because I don't know that we kept that constant for everybody. What would be some things? Okay, the amount of ice would be good. The fruit flies themselves, the type of flies that you're using would be a control because you want to make sure you're using the same kind. Exactly.
Are you working with anybody?
Okay, the same beaker, exactly the same setup. You can think of it like that. Okay, the same vials, exactly, yeah, the same kind of vials. And with the vial, I would include the foam thingy, foam stopper. It's a good scientific term, foam thingy. Foam stopper. Anything else that we'd be keeping the same? Now, I would like to go back to, and I apologize for not knowing your name yet, to the earlier comment. The time that you keep the flies off the ice, if you're setting up an experiment, yes, that would be something you'd want to control, okay? The reason I hesitated on that was because we didn't have everybody doing the same for when we started. But it's definitely, when you set up your own experiment, you definitely want to keep the amount of time that you're observing them off the ice before and after as a constant. Yes.
One more piece. So if you're doing multiple trials, should you use 3 flies in one, 30 flies in another? Should you vary the number of flies in each trial? No, so you want to keep those the same. So if one group is using 5, and make sure every trial that they do has the same number of flies, right? You want to keep that control.
Also, if you're doing a controlled experiment, as Mr. Maskey says, you want to keep the number the same. You'd want to actually take the time to make sure you count how many you're doing and have an accurate count. Because we were discussing that in the one group over here earlier. They have many in their vial. And we weren't sure that you'd be able to get an accurate count, at least not until you got them all cold enough that they were very sluggish or they stopped moving.
So,
Okay, so next up, see it says designing a protocol. We were just discussing the fact that just for the sake of time today, normally if we had the whole day to do this, we'd say, okay, every group could do theirs differently. But we want to try to keep everybody on the same page just to get through for the sake of time. So when you first set up a protocol to test your hypothesis, remind me, what's the hypothesis? An educated guess, but you already made a specific hypothesis for this, right? What was your specific hypothesis?
The time on ice, how the time on the ice affects the time of the recovery.
Okay, so how the time on the ice affects the recovery. So, were you specific in that? Did you say the longer they're on ice, the longer it takes for recovery? Okay, I thought I heard that earlier. Okay, so if you have your ice, you've got your vials with your flies, now you've already taken them over, okay? and a stopwatch. We're not using stopwatches. If you want to on your phone, you could, or you could watch the clock up there. The red hand is the second hand. So what would be the first thing that you would want to do? What would be the first thing you want to do when you set up this protocol? Now, I will tell you, in the middle school, we don't necessarily call it a protocol. We'll say design the lab. Okay, same thing. Okay, a protocol just simply means what's your experiment going to look like? What's your test going to look like? Okay, so when you're designing this, what's the first thing that you had to do when we started? If you had the 2 vials with the flies, what was the first thing you had to do to them? You had to tap them to the bottom, okay, and then transfer flies over to the empty vial, correct? Okay, so that should be your first step. So when you first sat down, you want to write this down underneath where you see the materials. Your first step was to tap your flies. You're going to tap your flies to the bottom. And then you can combine it all in the first step, or you can make a second step of flipping your flies into the empty vial.
Tap flies in the bottom and flip them into, you can decide if they make that 2 steps or just 1 step.
It looks like an old-fashioned goblet, just for decoration.
Now, I will tell you for what we did, I don't know that you need to add the next part, but if you were actually designing an experiment where you were going to test this for a research project, what did we take notes to once you tapped them and flipped them? What did you have to do before you got to that point? Yeah, you had to put in the foam stopper very quickly so that you did not lose your flies. Okay, so you want to make sure to mention that idea of making sure to quickly put in the foam stopper when you separate the vials so you don't lose all your flies.
So forget to put that in, guys, but the first stopper, put it in. Put it in, you put the stopper in both of them.
Okay, so now we have your flies in the empty vials that we started with. So it's basically what you're looking at right in front of you. What's your next step going to be? What's your next step going to be?
Let's do it after that.
Okay, so get an inch of ice into a glass beaker.
We're dealing with the observe the bill before.
Yes, and that's a good point. Observe them at room temperature. Here you also want to keep in mind, before we get the ice, you're going to observe them. How long would you observe them? We didn't give you a set time, but when you set up an experiment, you always want to come up with a given amount of time. You don't just want to leave it open-ended. So how
What do you
long?
think you would do? How long do you think you would want?
How long do you think a good amount of time to observe them would be? Yeah, 3 to 5 minutes is
3
good.
to 5 minutes is
Yeah,
good.
3 to 5
Okay, so
minutes
if
is
you didn't put
good.
that down for step 3 or whatever.
If
put
you
down
like
observe,
3 minutes better, put
observe
3. If you like
3
5
flies
minutes
for 3
better,
to 5
put
minutes
5.
at room temperature.
You want to put the 3 to 5, that's fine. Then, once you've done the observation for 3 to 5 minutes, then you'd want to go to your next step of getting an inch of ice in the beaker. Don't write this, but this is just a question for me. With using the glass beakers, could you easily see what the flies were doing?
Yeah.
Yeah, it seemed like that went a lot better this year compared to when we tried it last year with the solo cups. That didn't work real well because you couldn't see, as well. Okay, so once you have your ice in the beaker, what's your next step? Okay, so how long are you going to observe them in the ice?
How long did you observe them in the light?
3 to 5 minutes. I would say closer to the 5 minutes just to make sure that you see what you want to see. And I'm going to tell you, when you actually run through this and try it with timing it, if that 5 minutes you're not seeing a whole lot of change, you may want to go back and change out your 5 minutes and extend it. You might go to 8 minutes, but it's one of those, start with an idea and then go from there. Because one thing, and I'm sure Kayla would agree with this, from working in a college lab setting, is when you start your experiment and you run through what you think is going to happen, the odds of what you think is going to happen and what really happens are about 50-50.
Maybe even less.
Maybe even less, exactly. Because oftentimes what you think you're going to see is not what you see at all. And that's not a bad thing. That's one of the neat parts about science, the fact that you can be totally wrong when you start something. And if you figure out why you were totally wrong, it's all good. So it's not like if you're totally wrong, you fail at something. It's not the case. In science, if it's totally wrong and something totally different happens, then you just have to try to figure out why. Why did that happen? Okay, so you've got your ice. Then what's the next thing you're going to do after you observe them for 5 minutes? Okay, you're going to take them out of the ice. Take the vial out of the ice. What are you going to do after you take the vial out of the ice? Observe. Yep. For how long? Okay, observe for 3 to 5 minutes. Here's the thing. We're going to observe them for 3 to 5 minutes, but if you look up top, it says be specific about how to determine recovery. Okay, so what are you going to do while you're observing during that 3 to 5 minutes? What are you going to look for?
For them to go back to the top.
Okay, so if that is how you're going to decide it, that they need to go back to the top or be crawling or flying back toward the top, then that's what you want to put in as your next step. Or behind there, make a note that recovery is going to be when they're actually going back toward the top again.
So define what is recovery.
Yeah. So
Is it
actually
all the way
be
at the top
specific about what
or-
you're thinking of as recovery. Do they have to be up at the top on the foam, or do they have to just be going toward the foam? You want to be very specific about that.
Do you want it to be as they're starting to open up, or are you going to make it they all have to be there? So that's what they're doing on the glass.
And that's a good point. Is it going to be just the first fly? Is that when you're going to mark it down? Is it going to be the last fly? How are you going to determine what recovery is? Or are you going to do recovery times for each one of your flies that you see? And then come up with an average. That's another way you could do it. The step you have where you say about observe the flies for 3 to 5 minutes or 6 to 8 minutes, whatever you've decided on, put a note with that observe them for that long to see how long it takes to recover. Okay, because again, you want to be specific. Okay, so you're looking to see how long it takes to recover. My 8th graders are notorious for not including what I think of as the next step or as part of that step. While you're observing for recovery, what should you be doing?
Taking notes.
Taking notes, and what are you taking notes about?
How, like what they're doing.
what they're doing, and also how long it takes, yeah, what they're doing and how they're recovering, like what you're seeing, and also how long. Like, I oftentimes read lab reports from my 8th graders that they nowhere record their data. And I always say, data, question mark, because they forget to put a step in saying they have to record the data along the way. So you want to make sure you've got a step in your protocol or in your experiment where you're writing down what you're actually recording. If you need to make a graph, that would be a place where you'd put it. Okay, so we've gotten to the point where you're observing them after the fact. You're going to record your data. And then, what's the last thing we're going to do once you have your data recorded? What did Mr. Seifert talk about this morning when we were all together in the library?
Clean up.
Yeah, cleaning up, exactly. You want to make sure you clean up, and in this case, by clean up, we're actually going to be taking your flies and putting them back in the original vials that we got them from.
Mrs. Seifert was kind enough to get rid of your wastewater, but that's one thing she got to do, that she
Yeah.
insisted she didn't.
Tell me why, I'm just going to borrow this, why wouldn't you want to just leave this sit on the table when you're all done? There's no food, exactly. So these guys would actually starve because there's no food. So that's why we're going to make sure we put them back and we clean up when we're done. All right. So, next up, you're going to actually go through. Now we're going to be timing it, and you want to go through and on to the next page. And you can see it talks about data collection. And then you guys can just go ahead pretty much and dive right in. Okay?
Okay, so basically what you're going to do now is you're going to just look up, experiment, and now you're going to go through and you're going to do it.
So you've got to try a different number of minutes. So you need to decide this through. You actually have to go on,
You already had your
so you're going to do it 2 minutes, and then take a break. You're going to do it 3 minutes.
Now,
Go back into it. 4
would
minutes,
someone
take
need
a
to
long,
have
5
something
minutes.
stopwatch?
Okay, you guys decide.
That's the same for you guys. You're going to use your stopwatch, you're going to use the clock. Someone's going to call, someone's going to call time. Someone's going to be.
So then,
Yeah.
you know how many minutes you're gonna leave?
Well, you just need one. You don't
Like,
need
what are
one.
the what are the different times that you're gonna do? So are you gonna do the first one just for 1 minute and then figure out the recovery time, and then the second 5 minutes? You know that you're gonna figure out how to time your time.
Okay.
You guys have to plan for how many
Yeah, right out front.
Yeah, we can do 2.
So when they supposed to draw,
you'll want to run different times
supposed to draw the situation or?
My thought is, for right now, we'll just have them do their actual experiment, but we have the scope set up that they can actually but then they're changing it as they get to this part. Like some are doing 1, 2, 3, 4, some are doing 2, 4, 6, 8. So
2, 4, 5, 6.
So if you're gonna do that, that's time wise left on the right. Yep.
That
Yeah, remember, you're writing, I don't know if you want to write numbers down because you never used the timer before, so maybe you're really not going to notice anything for the first 2 minutes. No, I think you just use it. I mean, if they start flying up, you're going to start from there. Get your ice. You decide 5 minutes. Okay, so then you're gonna.
Alright.
Okay, now you want to put it in and you time it for 5 minutes. As soon as you have it in, is everybody ready? Get the time set, and as soon as you put it in, then that's when you want to start counting down. You can either count up or count down.
I'm ready for that phone call. You can't take it, you can't put it in
Finish it in.
2, 1.
And she said like it's a good, I'm in a good position. Like it's not like I have enough. So,
Brady, you can be the recovery time. Yeah. So when you make sure it's on.
This is just, you're not doing anything here.
So then you just press it as soon as this is done, then we take. Are we gonna wait? I just put it for an hour. Then it's not. Are we gonna wait until a majority of them like go up? No, we're gonna do an average. We're gonna count each one, and we're gonna write whenever a new one comes up, then we're gonna write time and then we're all gonna average it.
Oh, okay, so you're
So we're gonna add them together and then divide it by how many people.
so that's.
Should we really stop? Should we really seconds? Huh? Seconds? No, just do seconds because it's not gonna be in the middle of a second. Justin. You just destroyed your notebook and it's only been what? You were here last week. I lost my notebook. You lost it? Brady, get ready.
Okay, then when you pull them out in 5 minutes, then you want to.
I just made it halfway. So far, none of them went down.
You have to keep.
So recovery time might be 0
So you guys
seconds.
solved in 1 minute on ice, they recovered in 48 seconds.
Is your recovery time to be when they start to go down? You might want to change this, because what's.
If they go down at the last. Oh, I saw someone go down. 4, 3.
You guys are in your class.
Okay. How do I stop? Alright, 4 minutes. So what's the recovery time? We gotta wait until that one comes. So it's 13 seconds.
Average.
Yeah.
5%.
No, wait, hold on. All the other ones had 0 seconds and one of them had 13 seconds. So wait, hold on. How many are up there?
And Sue does. She does a lot.
7, so 13 divided by 7.
Okay, and what are your observations or notes?
That's 3.
What's your observation? What did you observe? What are your notes? Don't forget that.
That's more record note. That's wonder meter 6.
And they can do that.
Yeah, but we don't
You
want
want to calculate average or percent. Yeah.
Don't even do that.
And you can do it like inches or like a table.
No, you're doing
Okay, so ladies, already doing your easy lay all down. Okay, then I will keep going the way you are. because then it's like 2 minutes, and maybe what you're gonna do next.
So what?
You can't even do it here.
No, it's one.
So all of them have to be recovered, yes?
I like one or, you like one or two.
So then when you pull it out, you come to that, what they're doing. Probably want to start, when they come to start, they don't count up. See when they're doing the process.
You can go either way. That's probably a little bit more difficult. Yeah.
So why, are you good with that one?
Yeah, 1.8. Okay, that up really bad. It's 1.8. So then I was right. I went second. It's 1.8. I got it right. He told me it was 1.6, and I thought I got it wrong. So then I crossed everything out.
One in the middle, just stay.
So I was right.
Go back.
You don't forget your observation.
There's a couple at the top, but-
Those are probably at the bottom. Okay, if we're going to go back and right most flies is up to the bottom. Oh yeah, there's one. You have to go for
It's like saying when you're out playing in the snow and you come in, you're really cold, your parents should buy all the shit to see if you can. Not exactly.
Ryan, I just looks like it's a little extra.
I'd say it's
I thought it was an eraser.
0, start counting, pull it out. Ready, go. There you go. Okay, now you wanna watch, and what's your recovery? When they're all up, or when, or when what?
Going the right time.
Alright, so the first one, what should we do next?
Hey now.
4 minutes.
I don't wanna touch it.
4 minutes, okay, so Katie, do you want to get the timer ready? What do you think?
Yeah.
Okay, then go ahead.
Alright, so now we're doing 4 minutes.
I don't even know. By you moving it, you're
If I could have done this just
Yeah, you're right. That's all I'm about control. You just
Okay, set the timer for 4 minutes.
Oh, should we be ready? Yeah. Hold on. 2, 1.
And what's your recovery? I think what's your
Okay.
What's the
2? Yeah. I need to try one.
No, they decided.
Yeah, I forget. It doesn't. I forget my tables. I have to do all the things now. I forget all my tables. I know. Another version. I can go pretty far. I can go. Multiplication or yeah, the dragon or the two aspects. I don't care what. It's 18 divided by.
Just do 66.
I have to do that with the remainder or decimal. Remainder. Decimal. Then that's I mean, I didn't have a problem with it. Oh, I know what you can do. Whenever fly comes up with magic. So let's say fly's about to come up. I just go, okay, so a fly's coming up, lap it. That's the time of fly.
It's not.
Yeah, you can do that. I don't know how to do that. This is a lap. No, that's easy. That's easy. Look, I used to do this. I used to see what my face was. I used to got.
Maybe they think it's gonna come.
It's 3.63.
Yeah, they should be safe. I mean, it's just a little.
Divided by 5. This one just coming right. Let me check that. Where's the 80?
See, we did that with in 8th grade, like days.
Probably. I didn't search that up.
And we talked about
It wasn't me. I don't even watch cricket.
seconds as opposed to minutes.
What was it again? T divided by 5? I better be right, or else I forgot how to do it.
Because their ability to take
I could have
a
just.
point part of a decimal part of a minute is not good.
I don't know why I didn't study.
Just to make sure it's
Yeah, I got it right. I know that's easy. I have a problem. Stop.
Okay, how much time's left?
So you're so Stop laughing at it. What if, with the, Brady, you have to delete all those because the recovery time is coming. They're still all at the top, a lot of them. Go down. Yeah, go down. Let's make a
We want to do like a clustered line graph where they all just plot their points on it.
Maybe we could see if the ratios are
Just have them come up and plot
equal.
like that.
Say 2 minutes to 1.8, then maybe. I got to 1,000.
Yeah, one fell down.
Brady, there's 40 seconds left on the bedtime when it's scheduled, like a bedtime. Brady, 20 seconds left.
If they liked it, if they did.
Come on, Brady.
We're done. Because it was not good. Anything.
You have it. Yeah, I don't think that many went to the back. Go to the bottom again.
Well, that's what I'm saying, next time, put them on, next time you do it.
Nope, still more have to come up. Alright, when you push the lap, I have to add all the times together.
Colleen, do we want to change the recovery time to minutes or keep it at seconds?
No, I would keep it at seconds because it's more accurate.
Okay, so
Leave it on,
I'm
and then when another one comes up,
It
push
should
lap.
be seconds, so like how many seconds are in a minute?
That's the same as no.
We also gotta keep track of ones that go down, so we don't mistake them.
Make sure you guys keep your recovery time in seconds.
1, 2, 3, 4, 5, 6, 7. I got 7.
I'm going to do my mind up to scale. 10? 10 seconds? We're going to do like a class consensus and then we'll copy it down.
Yeah, there were 7 to begin with.
How many up now?
I can't see the other side, so I would guess 7.
How was your vacation?
I think that's how many we had. 13, yeah.
I went to the beach, and then a couple days I went to Disney because I was in Florida.
Brady, you can stop it now. I think they're all up.
It was
Yeah, so what are the times? Just okay,
Yeah, you gotta keep reading it second. You gotta read the second.
it was really hot. Yeah, but Disney is always busy. Actually, it rained the days we had there, which cleared out the parks, so that was nice. But then after the parks kind of cleared out, we got on rides, but yep.
Yeah, but no, Brady, don't write that in recovery time. No,
Yeah.
hold on.
Recovery time, it has to be in seconds, it's not a minute.
Yeah, but we still have to add it on again. Yeah.
Well, no, this is the total time. This is the total time, so that doesn't change.
Yeah, but we're trying to find like the
Oh, well, okay, but this is
Each experiment.
this is just like 4 minutes, the total time of that.
For each one, you know?
Wait, we need to check the last one.
This one's probably waiting for 5 more to go.
Right, yeah, last one we switched to water calculation. Only 13 seconds. Yeah, because Brady just sat there behind 6. No, none went down. None went down. You just gotta make sure everything's, oh yeah. Make sure the balls are all up. No, keep tapping, tapping, maybe keep tapping.
How many of you guys have?
Yeah, they're like getting really watery.
And then you can drop it out and get her. Do that.
That might be pushing it, yes, I agree.
Just one thing else.
How long was the flight?
They did 5.
Okay.
The next time I'm not gonna go. Yeah, they can grade this 7th grade. You're going to 7th, okay, and what they're doing. Parkinson and
Yeah. No, because I have like, I'm pushing start.
oh, you're okay. Where did you go? Do you live in the white?
It's raining.
I haven't heard a lot about it yet.
64 laps. Wow.
I didn't know what to about. I think it was science. It takes a lot. I'm fine. Actually, no, we're like 4 minutes. I just want to
So you might want to.
Oh wait, maybe I'm not. Now we're friendly with this. Yes. That's
the last
Yeah, we're all just
Are you gonna eat your homemade pizza this time? I have spaghetti and meatballs. For lunch? I can more than
like I said, I haven't been down there.
And then, so are you making your own food? Is that your own food?
Even if they were this big, because they are going to vertical spacing.
Already have It's not even covering me. It just wants to sit at the bottom.
Which one? Is it just that one sitting there?
Oh, one of them.
Watch two here, look. Your tube is against your ice. Or almost, that, that might, you have to be careful when you're setting
What's the time?
You can see it.
Yeah, I know, I saw it. But I don't like that. It's dumb. I got What? No, don't touch the wall. Don't touch it.
Oh, you're watching over here.
It's taking them a while. They did 5 minutes on ice and it's,
Oh, you started with the 5, yeah.
yeah, but there's somebody just moved there. There are 3 now. There they go. Okay.
What's your
I didn't get it yet.
No, like what is your?
Well, no, I think
What would you? Yeah, but what do you decide?
Oh, yeah.
Now you already look up here. So while you're finishing up collecting data, we're going to have kind of a class consensus. We're going to compile everybody's data on one line graph here. Okay, so for instance, if I was in a group that collected time at 1 minute, okay, the time on ice was 1 minute, and I found that it took 60 seconds for the fly to recover, I'm going to come up here and I'm going to put a dot at 1 minute. I'm going to put a dot here add 60. Now, there are 2, 4, 6 groups, so I'm going to expect multiple dots, right? So if 3 groups took data at time 1, how many dots am I going to expect on this column here at 1? 3. I'm going to expect 3 dots somewhere where they found was their recovery time. Ideally, they're all going to cluster around a similar point. Ideally, they probably won't, but we'll go at that when we get there. So while you're finishing up collecting data, if one person per group wants to come and start getting their points plotted on here, and I'll be up here to help you get that done. Okay, so we can start kind of getting trends. So one person per group, come up here, start plotting.
It's because most of them stayed up late. That was your first one? Yes. Put it in there.
Just put it
10 minutes.
all the way. Okay, so you did 30 seconds.
Yeah, so it's 14 times 60, which is not added on to the second, because they have to do it in package.
What do you, where's your
Yeah, still not.
Okay, so it's 2 minutes. You have 20 seconds.
4 minutes. Read it. 6 minutes long. I'm trying to see. Buddha.
And what else?
Who's gonna go farther?
Okay, keep going.
Alright, Brady, the last one just came up. Get your phone off the chair.
You guys have different ones than they do. So they have 13 seconds and 82 seconds. You guys have 1.8, 13.
4, 5,
Wait, what minute? 2 minutes.
How come you guys are different?
Peter. This 13, that's 82. I thought it was 1.8. No, I didn't do the average. It was 1.8. You kept doing the laps, so that's what made you get that. No? Yeah. When there was only one that had to come. Oh, it's the same version. It's 13 The first one's not the second one's 8.
It is.
No, the last one changed. And I know, but it can get you higher times because we said check the last one. Is it not the first
16 times 60,
It does.
92 plus 22, 93.
Or you can do 16 times 6.
What's the
How many seconds is that?